What's up, guys? Day three. Just so you're aware of what's going on today, we're going to do something really similar to what we did yesterday by doing a lesson for 10.6 today. All right. The only difference is I'm not including my webcam because I feel that I can pretty much just go through the examples with you on here on my screen, and it should make pretty good sense to you. All right. So I can kind of just walk you through the examples today on my screen. And again, hopefully it makes sense to you. Now, remember, a couple things. It's pretty much the last time I'm going to remind you of this. All right. Because when we come back from break, kind of expect us to know this, and I can start making these videos a little bit faster. One, we can pause, and I'm going to ask you to pause. Throughout the lesson to try certain problems. Two, you can rewind and go back and look at examples again if you're confused, okay? And hopefully it clears it up for you. Again, if we just remember these things, guys, I'm not going to really mention it again, then you can go back through this stuff and clarify it for yourself, and I don't have to make these videos 30 minutes long, okay? So I can fly through the examples a little bit faster, okay? So here's the deal. If you read what 10.6 is, we're going to be writing things in scientific notation today. All right. So a quick reminder and a quick warm up of what we did yesterday. We took numbers that were in scientific notation, like these, and we wrote them in standard form. All right, meaning we wrote out the actual number. Now today, what we're going to do is we're going to take numbers that are in standard form and we're going to write them in scientific notation. All right. So right now, let's get our materials ready to go. And I want you guys to complete these 6 problems as a warm-up. So after you come back, I will have your answers popped up. But at this time, let's pause our video and finish these 6 problems, please. Okay, so here are your answers. All right, here are your answers in standard form. Okay. Now again, here's the deal. If we kind of know this concept, we should be in decent shape for today's lesson. All right. Because again, it's the same concept. We're just going kind of backwards. All right. So what we're going to be doing is, for example, taking things like this, and we're going to actually move our decimal now from the end of the number back to right after the 6, and we're going to write it in scientific notation ourselves. All right, we're going to take numbers like this. We're going to move our decimal to the right, for example, 4 units to make the decimal be placed after the 4, and then we're going to write it in scientific notation. Okay, so that's just a quick example of what we're doing today. All right, so let's get into it. So I'm going to scroll to our first page, which is page 444. All right, which is where 10.6 lesson begins. All right, so do me a favor. First thing I want you guys to do, your learning target needs to be written in your notebook. All right, your learning target today is I can take numbers written in standard form and rewrite them in scientific notation. Or you can write it as I can rewrite numbers in standard form in scientific notation. Okay, so write that down. And then we're going to start reading this together. All right, we have a couple steps here today of how we're going to do this. All right, so let's read this together. I'm going to make it a little bigger so you can see it. So how do we do this? Writing numbers in scientific notation, our key idea. Step 1 says move the decimal point so it is located to the right of the leading non-zero digit. All right, I'm going to explain what that means more in a minute. And step 2 is to count the number of places you moved the decimal point. This indicates the exponent of the power of 10 as shown below. All right, so here are a couple of examples. Starting with a number that's greater than or equal to 10. Let's remember that for something to be written correctly in scientific notation, the first number, the factor, has to be greater than or equal to 1, but also less than 10. All right, so every time we're going to have to figure out, where am I putting my decimal? Where do I need to move my decimal so that my number is written correctly in scientific notation? So if we look at this example right now, if I am moving my decimal, which always, guys, if it's a whole number like this, my decimal is not going to be shown, but it's always at the end of the number, right? So for example, 8,600, my decimal's here at the end where my cursor is here, okay? And I'm going to move between the 8 and the 6 because that's going to make my number right here greater than 1 but less than 10, all right? So I don't want to move my decimal to after the 6, right? If I put my decimal after the 6, that would be 86 times 10 to the second power, when 86 is greater than 10, so it's not written correctly. All right, so the first thing we need to figure out is, where does the decimal need to move to? And then you're just going to count the number of spaces that you're moving it, okay? So let's remember this. If it's a larger number that we're representing, like, 8,600, we're always going to use a positive exponent for that. All right, now let's look at something where we're going to use a negative exponent. Really, really small numbers, okay? For example, 0.0024. Numbers that basically have a lot of zeros in the front of the actual numbers, the whole numbers, those we're going to use a negative exponent for. All right, think about it. We use positive exponents for large numbers. We use negative exponents for small numbers. All right, so now it says use a negative exponent when you move the decimal point to the right. All right, so if I'm going from where my decimal is here, which is where my cursor is, I need to put it between the 2 and the 4. Remember, I need to do that so that it's written correctly, right? If I put it between the 2 and the 4, that leaves me with 2.4, which is greater than 1 but less than 10. So that's what I want. So how many spaces did I have to move my decimal to get it there? 3. All right, since I'm representing a small number, I'm going to use -3 as my exponent. Okay, so that's the gist of it. So let's give it a try for example 1. All right, let's give it a try. So it's basically giving us a scenario where, why would a big, large number be used in the real world? Or how can we rewrite this large number in scientific notation? Well, it says Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. All right, so here's the deal. I want you to think real quick, where would my decimal need to move? And that, as of right now, my decimal is at the end of this number, right? This is a period, but we should know that the decimal is at the end of this number because it's a large, large number, right? And our decimal is always at the end of the number if that's the case, after all the zeros. So you should be thinking right now, where would my decimal need to move? And the answer to that is it's going to go between the 1 and the 6, all right? Why? Because that makes the number greater than 1 and less than 10. If I put it between the 6 and the 5, 16.5 is greater than 10. That's not okay. All right, if I put it after the 5, the 165, that's way greater than 10. If I put it in front of the 1, 0.1 is less than 1. All right, so there's always a specific spot where our decimal needs to go. Now, guys, I'm just going to see how many places do I have to move my decimal to get it there, to that spot. Okay, so if we read this, I'm going from here to here. How many spaces did I go? 9. All right, and since it's a very large number, if we read over here, my exponent should be positive because the number that I'm representing is a very, very large number. Okay, so how do we write it? Our final answer is right here, 1.65, right? Do I need to show all these zeros? No. 1.65 times 10 to the 9th power would be our answer here, okay? So the non-zero numbers are the numbers that I must show when I'm writing in scientific notation, okay? All right, let's give it a shot with another one. All right, so right now I want you to pause it and think about what you think our answer would be here. And when you come back, I'm gonna walk you through it. Okay, so pause it right now and get an answer down for this. Okay, so I'm going to use blue. I'm going to use blue because I have a very large number, okay? And I know, because I have a large number, I know in my head, I'm going to use a positive exponent at the end, okay? So here's the deal. My decimal's here right now, and I have to get it. I have to get it to here, okay? How many spaces am I going, guys? 1, 2, 3, 4, 5, 6 spaces, okay? So here's my answer, 2.45 times 10 to the 6th power, okay? Again, hopefully that makes sense. We always use any whole numbers when we write in scientific notation, but we don't need any zeros. Okay, we don't need any zeros. Hopefully that makes sense to you. Let's move on to doing the same thing, but with smaller numbers. Okay, so in this case, I got this really small number with a bunch of zeros in the front. All right, so hopefully right now you're thinking, since it's a small number I will be representing in scientific notation, I'm going to use a negative exponent, okay? Now we just have to determine what that exponent is, meaning I need to figure out how many spaces I need to go to get my decimal in the right spot, okay? Hopefully we're thinking, guys, our decimal needs to go right here, between the 2 and the 6, okay? Got to go between the 2 and the 6 to make the number greater than 1 but less than 10. So here's a context of where these numbers could be used in the real world. The 2004 Indonesian earthquake slowed the rotation of Earth, making the length of a day 0.0000268 seconds shorter. Write this number in scientific notation. All right, so here it is. Remember, I got to go here because it's great. That makes my number greater than 1 but less than 10. How many spaces did I move it? 6 spaces. Okay? Because it was going to represent a very small number, I'm using a -6 as my exponent. All right, so here's my final answer. Remember, any whole numbers that are not 0 should be used in our factor, which our factor is this number here. All right, but I moved it 6 units. I'm representing a very small number. Okay, so -6. All right. Same thing. Let's go to the extra example. And I'm going to have you guys pause it and try and come up with an answer here. When you come back, I'll go through it. So pause it at this time. Okay, here we go. I'm going to use red. Why? Because I know I'm going to be using a negative exponent. Okay? I know that because it's a very small number, guys. All right? So hopefully we're thinking, here's my decimal. I have to move my decimal right there between the 4 and the 5. All right, so again, I'm just counting 1, 2, 3, 4, 5, and it's 6 again. All right, so my answer is going to be 4.5 times 10. Only times 10, obviously. To this time, it's the negative 6th power. All right. Should be pretty straightforward, guys. If you're noticing something, it's kind of the opposite from yesterday, right? If we move our decimal right today, we actually use a negative exponent for that because we're going backwards. We're going backwards from yesterday. So everything's backwards from yesterday. It should make sense. All right. Let's get out of here. Here are your on your own questions. Here are your on your own questions. So again, at this time, do me a favor. You're going to pause your video. When you come back, answers will be up. So at this time, pause your video, please. Okay, here are your answers. I'm not going to sit here and go through every single one of them, but again, just kind of pause it if you want to check your answers quick. I'm just going to keep moving though. All right. Okay. Final thing that I want to show you today, kind of the same concept as yesterday, is what if we have to, this isn't it. What if we have to compare Here we go. What if we have to compare numbers that are written in scientific notation? Well, one way we could do this, guys, is you could do what you did yesterday, and you could change them and write them in standard form and see which ones are the greatest. Or I have a different way to show you. All right? My thinking here is if I look at my numbers, these are the three numbers basically that I'm comparing. It says the table shows when the last three geologic eras began. Order them from earliest to the most recent. So from least to greatest, basically. Okay? From least to greatest. So actually, maybe it's from greatest to least. Yeah, it's actually greatest to least. But regardless, if we can just compare, that's the most important thing. So here's my thinking here. The lowest number has to be this one because I see two numbers. I see two numbers written in scientific notation that have exponents of 8. Okay, since this has an exponent of 7, I automatically know that that number is smaller than those other numbers. All right, I know that this number is smaller than these numbers. Now, if I'm just comparing the two numbers that have 8s with exponents, all I look at is my factor. All right, since 2.51 is less than 5.42, since they have the same exponent, I know that 2.51 is less than or a smaller number than 5.42. All right, so what I would say if I were going least to greatest is this number in the middle here. The Cenozoic era is the smallest number. The Mesozoic is the next smallest, and then the Paleozoic is the highest number, the greatest number. Okay, so since this was kind of backwards to me, since they were talking about the earliest to the most recent, actually the greatest number, because it's years ago, the greatest number actually went first. So they were ordering them from greatest to least. But again, most importantly, can we compare these numbers? Can we just compare these numbers? That's what we're looking for. All right. So let's find out if we can. All right, let's find out if we can do that. So now it's asking us to order these numbers from least to greatest. All right, least to greatest. So do me a favor. You're going to pause your video and you're going to give this a shot. So at this time, please pause your video. Okay, here's what I'm going to do. I'm going to put a 1 next to the lowest number, or kind of near the lowest number, a 2 next to the second lowest, and then a 3 by the greatest number. All right, so hopefully this is what we're looking at. I look first at my exponents. All right, see, I see this 5 right here, and then the other ones are 10 to the 4th power. Guys, I know this is my greatest number right here. That has to be my greatest number because it has the highest exponent, right? Now, I'm looking for the lowest first, right? I'm going to look at these two numbers that have 4s as exponents, and I'm going to look at their factors. All right, I'm going to look at their factors. What's the lowest number here? 5.65 is our lowest number. Okay, it's lower than 6.8, so this has got to be our lowest number. All right, so I'm gonna put a 1 down here. That's our lowest number. Since this number has an exponent of 4 as well, and remember this has an exponent of 5, I know this is my second lowest number. All right, which means this is my greatest number. Okay, so again, hopefully today's lesson wasn't too hard. I feel that this is pretty simple, and you guys should be just fine with this concept. But as always, like I said yesterday, I will have a discussion board in Canvas. All right, I will have a discussion board in Canvas where you can go to ask questions, and I will be in there live from 10 to 10:45, which is your class time. Okay, I'm also available from 1 to 3 every day. So if you have questions, ask them in there. You could email me. And another resource that I'm going to post is our Khan Academy guys got a video on this as well. All right, so if the way that I taught it didn't make sense to you or was confusing, guys, if you watch just up to 5 minutes and 30 seconds of this video, he goes over the same concept that we just talked about. All right, anything after that is a new concept that you don't need to worry about. So again, if you're going to watch this video and you're still confused and just want an extra resource, you only have to watch up to 5 minutes and 30 seconds. All right, because everything after that is something new. Okay? Anyway, if you think you're good to go, there's an assignment here. All right, here's your assignment. It's the 10.6 practice. Okay? Same kind of thing as yesterday. It's actually only 8 questions though. Okay? So the 2 things you'll have to do is 1, you will have to take numbers like we did here in example 1 and write them in scientific notation, example 2, and write them in scientific notation. All right, large numbers and small numbers. And the next thing you'll have to do in there is what we just talked about, which is where we're comparing our numbers, okay, that are written in scientific notation. Again, at this time, go into Big Ideas, sign in, and complete your assignment. And one thing I got to remind you guys of as well, when you're done with your assignment, you can't just close out. It doesn't tell me that you submitted it. You have to, at the top right part of your screen, click on your name. It'll drop down a kind of a drop down menu where submit is an option. You have to click on that. Okay. I have a lot of you that it says that you're in progress in assignments because you're not submitting correctly. Okay. Don't just close out. Go to your name at the top right, click on it, and click submit. All right. Now tomorrow it will just be IXL practice. All right. So that'll be Friday, and that'll lead us into spring break. Okay. So I will be in contact with you guys again tomorrow. See ya.